pleasure to welcome Dan, who is going to be talking in a way that's quite fascinating, linking what we grow with the effects on our health and what we eat. And I think that's just about the most important subject at the moment to be thinking about. So it is my great pleasure to welcome him. Please, round of applause.
Thank you very much. The intention of this presentation was to do a reprise of what already occurred yesterday morning. I don't know how many people were there and whether I should repeat myself or attempt to go off in a slightly different tangent. Please repeat. Tangent. 1-to-1. Any other votes? Repeat. Oh boy. Okay. With some tangents. Okay. So just quickly, my name is Dan Kittredge. I'm from the States. My background is as an organic farmer. I've grown up on a 55-acre homestead where we ran everything from milk cows and pigs and ducks and geese and sheep and goats and to a full spectrum of mixed vegetables, orchardry, pastures, etc. Among other things, my parents were the kind of farmers who couldn't make a living farming and had a day job, which was running an organization called NOFA, which they still do, which stands for the Northeast Organic Farming Association. It's something akin to the Soil Association. There's 7 state chapters in the Northeast region of the United States. So I have a background, A, as an organic farmer, B, as a sort of a member of the movement, quote unquote. My father helped write some of the first organic standards in the States in the mid-'80s, and they've run the annual conference and edit the newspaper and things like that. So with that all said, I have I take the liberty of speaking about organic and saying things that sometimes people don't feel comfortable saying. My personal experience after managing my parents' farm through college and into my 20s was that when I decided to make it a vocation, to make a living farming, I hadn't been able to find no other endeavor that felt so complete as far as the lifestyle and the deeper meanings of life was concerned. I rapidly came to the conclusion that I was like my parents, the kind of farmer who was unable to make a living doing it. And a large part of the reason why that was the case was that because my crops were simply succumbing to infestation and disease on a regular basis. It was just economically unfeasible based on the fact that my plants were sick. And I had been brought up in the dogma, I would say, that organic is better. At the farmer's market in town, we always held our noses a little bit higher than everyone else because we were organic. I was really confident in the fact that organic was better, and it was a bit of a humbling process to go through to realize that my plants were sick. I'm not sure what that noise is, but I'm sure it'll drop off soon. What's that? Oh, that would be wonderful. I got the spotlights right on me. I'm going to be perspiring shortly. I can just maybe pull out a couple metaphors that I didn't use yet here, just for visceral purposes. I remember one time I was walking across the driveway, checking on our old farm dog, Stu Ball, who had been run over by a CSA member the previous week. His rear end had been driven over as someone drove in to pick up their share and hadn't seen him or figured he'd move, but he hadn't. And he sort of got ground into the driveway a little bit. Nothing, no broken bones, just a yelp and a stop. And he got to hang out in the house for a couple of days. He was about 10 years old, an old lab mutt. His job was to chase coyotes and raccoons at night, keep them away from the animals. He got to hang out in the house for a couple of days and recuperate, and he seemed fine, so he was back outside, and he was laying in the driveway again and sunning himself. And I went to check his cut, and there were maggots in there. The flies had laid eggs, and the eggs had hatched, and the maggots were eating his flesh, which is nature's way of cleaning a wound. Some people may be aware of that. For me, it was a deeply I was able to keep my lunch down, but barely. But the point is that I had a 5-gallon bucket in my hand, and I was heading off to the potato patch to knock Colorado potato beetles off of the plants into the bucket before we would, dump them in the fire or whatever. Not sure if any you guys have Colorado potato beetles here, but they're quite a quite a pest. The only way we were able to keep the potato plants alive long enough to get some kind of a harvest off them was going through with 5-gallon buckets and knocking them off, every 2 days, basically. And, it struck me that larvae eating my dog would cause me to retch, but larvae eating my plants was thoroughly normalized. Similarly, we would plant cucumber plants every 3 weeks or so to have successions of cucumbers because powdery mildew would come and, basically take them out a few weeks after they started producing. And we had a CSA, and we wanted to be able to produce crops through the growing season. And the only way we could have cucumbers available through the season was if we planted successions. And I got to thinking about, a systemic staph infection or something like that. I like to say, if your chickens were being eaten alive by a flesh-eating fungus, you probably in good conscience would not slaughter them and feed them to your children or to your customers. But when my cucumber plants are being eaten alive by a flesh-eating fungus, I consider it to be totally normal. And I think, nature speaks to us in many ways. And as far as I'm concerned, being eaten alive by larvae or being eaten alive by a flesh-eating fungus is a sign of poor health. And many of us haven't necessarily put A and B together, but when you do, humility hopefully is part of the process. If you are using a fungicide or an insecticide, you may be killing the insect or killing the fungus, but you are not solving the problem, which is that animal or plant is not healthy. And so this was part of my evolutionary process of understanding, was that I was not able to make a living because my plants were sick. And so I, was delved into the literature, attended conferences, attended seminars, read books. I would study in the winter and practice in the summer, study in the winter, practice in the summer. And it took very little time to get to a point where the potato bugs no longer came. The cucumbers, you'd plant them in the spring and we would be picking them through till frost, same plants. I experienced on my farm profound transformations in plant vigor and vitality, which ended up correlating with economic vitality, right? I've gotten to a point as a farmer where I can make a good living without much work because I've understood how to create an environment where nature is able to flourish, where the higher organisms are able to really operate at a much better level. So it's those principles that I've understood in my process that I want to try to convey here today. Obviously, we have a very short amount of time, so I'll do what I can. And I think people are interested in what we're doing with the technology of testing quality and perhaps the broader movement strategically as well. So I'll try to leave a few minutes for that and potentially questions also. So, all right, there's the introduction. Just to reprise what I said yesterday, starting with broad strokes, most plants are green. Plants are green because they cover their bodies in chloroplasts, in which chlorophyll exists, and the process of photosynthesis occurs. Photosynthesis is the process of carbon dioxide and water and sunlight being converted into sugar and oxygen. People have heard about this. If you look into the actual technical dynamics by which it occurs, quantum tunneling, I think, is the best explanation they've gotten to. Like, how does it actually work that carbon dioxide and water are converted through sunlight into sugar and oxygen? It is really impressive what goes on in leaves every day. Like in science, if you try to explain it, it's really quite profound, but we don't have time for that. The point is, the oxygen that's made in the leaves gets put into the atmosphere, and in healthy plants, in nature, a majority of the sugar that's manufactured in the leaf gets literally taken down through the stem, through the roots, and injected into the soil. So plants cover themselves in green to make things which they then eject out of their body. And I've got a couple of foundational dogmas myself. One of them is that nature knows what she's up to. And if we don't understand it, that means we need to start paying closer attention. I think I said this yesterday. In none of the first 6 days did God invent fertilizer. Plants have been doing just fine without fertilizer for quite some time. In fact, we don't really see infestation and disease taking plants out in nature. We only see it happening in agriculture. So the foundational point here is it looks like the way nature has evolved the system to operate is similar between the different kingdoms. The way that animals work symbiotically with microbes is very similar to the way that plants work symbiotically with microbes. So the plants functionally make sugar to feed soil life, to feed bacteria and fungi, to feed, I like to say, their gut flora. People may be familiar with cows and know that if a calf does not get its colostrum when it's born, it'll likely be a colicky calf. It'll bawl, right? I mean, the sound of a bawling calf in a barn, anybody want to talk about that? How grating it is on your nerves? That is nature's fire alarm system, right? It just gets under your skin in a way that is, right? That's nature saying something's wrong. When that baby calf does not get its colostrum, it's in pain. When the baby human does not get its colostrum, it's in pain. The bawling, colicky child is one, in many cases, that does not have its gut flora well established. It is critical to have a well-established gut flora because that is what is evolved as your digestive tract, right? We're taught in school about the kingdoms, the plant kingdom and the animal kingdom and the bacterial kingdom, and foundationally that's part of this reductionist, flawed paradigm, I would suggest. Actually, it's a symbiosis. Something like 90% of the cells in your body are not human, right? You are primarily built of other organisms. What are you? What are we? We are an ecosystem. We're a symbiotic, synergistic ecosystem. And when your gut flora is functioning well, you're likely to be healthy. And when your gut flora is not functioning well, you're likely to be in rough shape. So foundationally, it's exactly the same with the plants. I like to say, I don't care particularly what kind of plant you're growing. I care particularly how well the soil life is functioning. It's the soil life that are evolved to digest the soil and to feed the plant. I like to use the example of the Grand Banks off the coast. Well, it's in, I guess it's south and west of Greenland. There's an area in the northern Atlantic where, at least from my perspective in North America, all of the fishermen from Newfoundland to New Jersey drive their boats to. They all drive their boats to the same spot and park there to go fishing. And they park there to go fishing because that's where the fish are, right? Obviously, if you're a fisherman, you go to where the fish are. And they figured out where the fish are. And the fish are all in one spot. And the fish are all in that spot because that's where all the food for the fish is. The phytoplankton, the microbes at the bottom of the food chain, are all extant in a certain area in the ocean because of the critical environmental conditions for them to exist are there present. We have the warm upwelling, we have the minerals, we have the sunlight. Only where you have the critical environmental conditions for the phytoplankton to flourish should you expect the fish to flourish. It's exactly the same for your plants. Only where you have the critical environmental conditions for the microbes to flourish should you expect your plants to flourish. So this whole conversation, I call it principles of biological systems, is what are the critical environmental conditions necessary for life to flourish? And so we'll try to go into some of these here. I'm going rapidly and hopefully maintaining some semblance of coherence. The microbes in the soil that are the gut flora for all your plants, whether it's a pasture or a grain or a vegetable or a tree, they all require air to breathe, right? All microbes are aerobic, soil microbes, well, not all of them, but all of our plants require aerobic microbes to function well. And so foundationally, if you don't have air in your soil, they're dead. If you put a plastic bag over a chicken's head, it's going to be dead. If you've got tight soil, the microbes are going to be dead, right? Nothing too complicated about this. So I like to suggest that if you are not able to manage your soil in such a manner as to maintain sufficient aeration, you should expect to have systemic issues, forthcoming. So how far can you reach your hand into the soil? Is it 1/4 of an inch? Is it 1/2 an inch? Is it 4 inches? Can you down to the elbow? In many cases, aeration is a critical limiting factor. I've been traveling now across the Isles for a week, and from what I can tell about the way the soils are managed, compaction is a serious issue. all the fertilizer, all the, other things you can purchase and apply are not going to solve the problem of compaction. Some simple techniques that can be utilized. One, we've got rippers, keyline plows. There are tools that have these shanks that can help to break up soil compaction. You can put planters in the back of them. I'm sure people know about this. You can drop in cover crops. You can drop in inoculants. You can drop in liquid minerals and all kinds of goodies. Generally, as above, so below. The taller the plant growth is above ground, the deeper the root growth is below ground. I've seen a lot of pastures that are managed in such a manner as to have them never grow really taller than just a few inches. And the mob grazing, the savory, the holistic management stuff, I think would be applicable for many people here. As far as a technique, the deeper the roots grow, the more they crack open the soil. There's the different kinds of plants you can put in your pasture. There's the anybody who's deep rooted, right? Anybody who's a deep rooted plant that's growing there is part of nature's way of trying to crack open those really nice, the strong like a dandelion or a dock or something like that. That's nature's way of trying to crack open that subsoil. Those are beneficial plants. That's nature trying to address that soil compaction issue. There's forage radishes. There's other plants you can put into the sward to help facilitate that process. But letting the plant grow taller, which means it's helping the roots grow deeper, this is systemically critical. If you're operating in a tillage environment, whether it's whether it's grains or vegetables, maintaining soil cover is foundationally important. This would be another critical environmental condition, which is food. Soil life needs food to eat. In nature, for microbes, we talked about the plants manufacture sugar in their leaves. That sugar is injected into the soil in what's called plant root exudates. Those are sugars with various amino acids attached to them. You basically want to be able to maintain sufficient food for the microbes to exist throughout the 12 months of the year. In the winter period, if you don't have cover on your soil, if you've got bare soil, the microbes are still living there. Right? They have not taken off to go south for the winter to stay warm. They're still living in that soil. And so maintaining organic matter, if it's not green, it needs to be brown. So mulch or cover crops that have laid down, letting the pasture be a little bit taller before the winter comes, and so it can lay down and serve as a food source for your microbes is foundationally important. Another piece of this puzzle of food is the topic of fertilizer. If you, I like to say, went to the hospital and had to have some serious surgery or other, and were, basically put on an IV drip, it is possible for you to be kept alive for an extended period of time with soluble nutrients being injected directly into your bloodstream. Right? This is a fairly typical process. I like to liken fertilizer to an IV drip. People, if you've ever read the number on a bag or the number on a bottle of fertilizer, 534, 10, 10, 10, 0, 52, 0, whatever the numbers are, that number specifically means soluble nutrients. And so what happens when the plant is fed soluble nutrients functionally directly into its bloodstream is what would happen to you if you're fed soluble nutrients. The gut flora, right, when you eat your food, a bunch of it, the roughage, the brown and the brown rice, all the nice stuff in vegetables, all that dry matter functionally is food for your microbes. And you as an animal can be kept alive through a soluble nutrient drip. The plant can be kept alive through a soluble nutrient drip, but the microbes get short-changed. And so when you add fertilizer to your field, you may be causing the plants to grow. I liken it to steroids, right? It looks like they grow big and strong, but actually they're systemically weaker. Really, we want to be facilitating a dynamic where the plants are making sugar and feeding the soil life, and this biological cycle is continuing. You'd like to have your soil covered with green at all points in time, undersowing cover crops into an annual system so that when the annuals are harvested, the cover crops are well established, and you can be cycling through the year from one crop to the next. Polyculture is obviously better than monocultures. These are all different pieces of the puzzle of keeping your soil life fed. Foundationally, they do need food to eat. And so To finish this, one more point on this topic, my understanding is that farmers managing the land well have been able to, and we got cases in multiple continents where farmers operating on significant scale have been able to increase soil organic matter levels by at least 0.5% per year, up to 1.5% per year for year after year after year after year after year, going from 1 or 2% up to 10 or 15% without problem, right? Continuously doing this. That process only occurs when you stop using fertilizer. The plant will not inject plant root exudates into the soil to feed the microbes when it's being fed a soluble nutrient drip. You build resilience, you build the water holding capacity. Right now you've got a period of drought. You really would like to have serious, stable organic matter in your soil to be maintaining hydration. Whereas every percent of organic matter adds another 25,000 gallons of water per acre holding capacity. So you can go through droughts much more well the more organic matter you've got. You build organic matter by having a functioning biological system. You add soluble nutrients, and that burns off the organic matter, right? I'm probably repeating myself. I don't want to belabor the point. But the larger point is, from an environmental perspective, climatically, globally, I think there's something like 10 billion acres of agricultural land, and if you were to be sequestering carbon at the rate of 0.5% per year on every acre of agricultural land, were global agriculture to be operated in a biological manner, we could sequester, I think it's 15 parts per million of CO2 from the atmosphere per year. There's been 125 parts per million added since 1750. So you do the math, and it comes out to about 8 years it would take to bring us down to where we were in 1750, were agriculture to be practiced well. In fact, I think something like 40% of the CO2 that's been added to the atmosphere since 1750 came from burning soil. The process of tilling soil, the process of adding synthetic fertilizers is a process of taking organic matter and turning it into carbon dioxide. It's not just the coal and the oil and the natural gas that's causing this issue with the atmosphere. It's farming done poorly that's causing this issue. All right, so we've talked about air, we've talked about food. Water is another one. Obviously, life needs water to drink. Obviously, many people are experiencing issues with that right now in their operations. Where I live in what's called New England, we have had in the past few years a very regular occurrence of 4 to 8 week droughts in high summer, which has created a dynamic where those who do not have some ability to maintain hydration are functionally losing their crop. And so I don't know what the weather pattern says and how long it's been going on for, but what I hear is it's starting to add up the number of days in a row with no rain, and the functional effect on your crop may be quite negative. Systemically preparing for too much water and not enough water, I think, is part of what we need to be doing as land managers in a much more systemic fashion. What I've done on my farm is to identify the areas, right? It's high over here, it is high over here, it is low right here. It may be seasonally wet in this low area. I just get a mini excavator, and you can rent them for not that much money. If you've got enough money, you can buy your own. But digging ponds, stockpiling water in the landscape where water would naturally pool, functionally is a great way to bring resilience to your land in that fashion. And then you can, if you've got some kind of a grade, you can have a pond here and a pond here and a pond here and a pond here, and you can lower the spillway and have it drain out when it's too wet, and you can lift the spillway and have it build up when it's too dry, and you can really modulate the water table in your landscape quite readily, very low tech, and it's great fun digging holes in the ground. I don't know, for some of us, I like to go out and play in the dirt. But the permaculture community talks about this, about stockpiling water high in the landscape. The keyline, principles developed in Australia are all about this. So just thinking about ways to passively manage water in the landscape so that you can, address excesses or deficiencies systemically, I think is really very important. If you've got pasture or you've got broadacre crops, you're probably not going to be putting irrigation systems in. but you can manage the water table fairly well. One point I made yesterday, which a couple of people have spoken to me about and said was thought-provoking, was the way that nature's irrigation system works. And to my understanding, there is this force operational day in and day out called the tidal force. If you go to the ocean, you'll see that the water rises and falls twice a day, and it has to do with the magnetic pull of the moon. I've always found it to be quite, impressive, verging on magical. How is it that the water goes up and down twice a day? It's kind of impressive. Maybe not everyone has that sense of wonder. Getting a bit of a flat visage here. It might just be the temperature. It doesn't just work on the ocean. It works on land too. If you don't have a plow pan, if you don't have subsoil compaction, tidal force will bring water up from the water table through the subsoil into the root zone and back down again twice a day, right? Just literally the tidal force waters your plants from below twice a day. The deeper the root systems, the less far up it needs to go for your plants to be watered. Subsoil compaction will prevent this from occurring, right? The capillary action will not occur when the soil is as tight to a certain degree. So another reason to be thinking about addressing this issue. Also, what happens is that this part of this process of the water being pushed up through tidal force, through capillary action, is that the carbon dioxide that has been emitted by the soil life, they're breathing out, is pushed out of the soil and used. Actually, carbon dioxide is food for plants, right? It's part of what they use to make sugar out of, carbon dioxide and water and sunlight. And so literally the soil will push carbon dioxide up underneath the leaves, the stomata open, the plants breathe, and then the tidal force pulls down again, and oxygen, which came out of the leaves, is sucked down into the earth, and the soil life is able to breathe. It's this beautiful, beautiful process, one amongst many that are naturally occurring if we are able to create a dynamic where nature really is able to function well. And I think there's any number of dynamics like this which are synergistic that we may not understand, which are quite powerful when we begin to address limitations in the system. We were talking about earthworms in the panel I was on before this morning. I consider earthworms to be a wonderful, wonderful, symptom of a well-functioning ecosystem. I think it's something like 15 earthworms per square yard equals 40,000 pounds of earthworm castings per acre per year. That's 1 pound per square foot. If anybody was to try to buy 20 tons of earthworm castings and spread them on their field, they would rapidly go broke. My understanding is a synergistic benefit of a well-functioning biological system is 20 tons of earthworm castings applied on my field as over the year, through the year, right into the root zone. So there's all these really beautiful synergistic benefits that occur. Again, I don't have too much time to go into them in depth. So air, water, and food we've covered, all of which should be relatively obvious when you begin to think about them. Life itself is another issue. I talked a little bit about colostrum. The baby calf needs its colostrum, after birth, before milk. It's colostrum that comes out of the breast. This material, it's a probiotic, it's a prebiotic. It's there to establish gut flora. When you're born, there's nobody between your mouth and your rear end, right? Your digestive system doesn't function until that community establishes. It's exactly the same for the plant. I suggest probably the step that would be of least difficulty, of least cost, least time consuming of all the ones that I'll be discussing here today. So then therefore, lowest hanging fruit, best place to start would be inoculation of your seed. If you obviously have a pasture, you got a little bit of a different issue, but if you are planting seed, ensuring a broad spectrum of microbes, dozens of families of bacteria, at least a dozen families of fungi in direct proximity to the seed as it germinates will functionally serve as a colostrum, will help to establish gut flora. It's an ounce of an inoculant, which could be good for 50 pounds of seed or 100 pounds of seed, depending on what size of seed. I'm talking about lettuce seed or carrot seed, not wheat or pea seed. 1 ounce of inoculant should be good for 50 to 100 pounds. Depending on what scale you're buying it in, it's just a couple dollars a pound, dollars an ounce. It's a fairly nominal cost, and quite a profound systemic benefit. Some people have heard of buying bean and pea inoculant. There's, I think it's the Azotobacter and the Rhizobacter that are in this package, and you can put that on your legume seed to help facilitate nitrogen fixation. If you're familiar with that concept, all you're doing is purchasing a inoculant that has a much broader spectrum of species in it. Certainly, one need not purchase inoculant. There are many ways of harvesting it from your local ecosystem, manufacturing it yourself. I'm not trying to say you need to buy something, but in concept, what we're trying to do is ensure this full spectrum of species is present. If DDT or glyphosate or atrazine or any number of other products have been spread on your land, it's entirely likely that these species are no longer present, right? They've been removed from the environment. Genocide has occurred, and they have been removed from the environment. And this is simply what's been going on. They are not there. I used the example of the snakes in Ireland. Until somebody brings some snakes to Ireland and lets them reproduce, there's never going to be any more snakes in Ireland. It's like that with Azotobacter or mycorrhizae. Right? Once they're out of the field, they need to be reintroduced to be able to set up shop. Once they're reintroduced, as long as you don't kill them off, they'll take care of it. Nothing complicated here. It's not the kind of thing you need to do annually, but it is something that one should be considering as a systemic step. The final piece of environmental conditions that I like to discuss is minerals. This is what I first really got excited about and started experimenting with when I was learning about all of these things, and I just went to a local quarry where they made granite countertops and took the cuttings that came off of the saw, which were just bulk piles of finely crushed ground rock dust, and went and spread them on a field. We had pulled the garlic, and we were putting in our fall brassica plantings of broccoli and cauliflower and cabbage, and we just took this raw granite dust and spread it on the field, and it was the sheen on those brassicas that fall was stupefying. It was just like there was a glow in that part of the field that absolutely was out of the ordinary, and that was my first taste of it, and I've since gone very far down the rabbit hole of understanding all of the correlations and nuances and implications. My understanding is that the soils here are in many ways similar to the soils we have in New England, in that due to regular significant rain, as in dozens of inches per year, and agriculture being practiced in the same spot for hundreds of years, we functionally have relatively weathered soils. There are simply minerals that are necessary for life to flourish which are not present anymore, or if they are present, they're present at really insufficient levels. And so addressing mineral deficiencies is a really powerful piece of this process. It's one I really like to go into, and I don't think I probably have time for it right now, but it really, it's really an exciting conversation. Let me just give you one example, maybe a couple. I talked about the bean and pea inoculant earlier. Mixed into bean and pea inoculant in the United States annually are 1 million pounds of an element called molybdenum. Molybdenum is an element on the periodic table of elements like calcium and zinc and sulfur and phosphorus. Molybdenum is at the center of this compound called the nitrogenase enzyme. Fancy words. I don't want to shut people off. I know as soon as you start sounding like you're a scientist, people sometimes they just turn off. But the Azotobacter, the Rhizobacter, these are the microbes that work to pull nitrogen out of the atmosphere and put it into the nodule on the root of the bean or the pea or the alfalfa. They have a tool that they use to grab that nitrogen. The tool they use, like a socket, like a wrench, like a screwdriver, that they grab it with is called a nitrogenase enzyme. It's got a certain size and a certain shape, and what gives it its unique size and shape is the molybdenum at the core. One atom of molybdenum at the center of this enzyme is necessary for the process of pulling nitrogen out of the atmosphere and making it available for your plant. 1 pound of molybdenum is all it takes in an acre to facilitate this process. And by the way, every family of plants, period, has the ability to work with bacteria and fungi to pull nitrogen from the atmosphere, right? Some people have heard the story that it's only the legumes that can do this. Not true. Not true. 60-year-old data tells us clearly that every family of crop plants has the ability to pull nitrogen from the atmosphere and feed itself. Right? On my farm, there's a couple of things I don't do. One of them is I don't kill insects. Another one is I don't kill diseases. And another one is I don't add nitrogen. I don't add compost. I don't add chicken manure. I don't add liquid fish. I don't add blood meal. If my plants can't harvest their own nitrogen, then they're not fit. That's my own personal story. I'm not saying anybody else needs to take that stance. But I'm saying, as I understand it, in nature, nobody's adding nitrogen fertilizer, and all the plants are doing well, and they are not all legumes. The point is, you need these elements in the environment for that process to occur. 1 pound per acre of molybdenum is necessary for this nitrogen fixation process to occur. Cobalt is another element we can talk about. Cobalt is the center of an element called B12. People who are vegetarians or vegans may have heard that they need to supplement their diet with vitamin B12 because they aren't getting enough of it. And in science, B12 is called cyanocobalamin. There's 1 atom of cobalt at the center of this compound. If you don't have enough B12 in your body, you become anemic or lethargic or weak. And finally, if you really don't have enough B12, you become dead. Right? We are B12 dependent organisms. We require a certain amount of this compound in our body to function. Interestingly, 80% of the species of soil life, of which there are millions, which are the bottom of the food chain, right? The phytoplankton in the ocean, the soil of 80% of the species are B12 dependent. If you don't have cobalt in your soil, you don't have life in your soil, right? Sulfur is critical for amino acids being complex into proteins. Boron is critical for calcium availability. There's a broad spectrum of elements that are necessary for biological system function. And they're not the ones that are necessarily recommended by your formal university government soil reports. As far as I'm concerned, between finely crushed rock dust, basalt, and granite that you can find at local quarries as the byproduct of road building, and sea salt or seawater, between rock dust and seawater, we have the full spectrum of elements necessary to remineralize our lands. This is applicable globally, right? I think it's 40% of the world's land surface has been desertified through the process of agriculture in the past 10,000 years. It's really quite profound. In many cases, systemic limiting factors are elements. That 1 pound of molybdenum, those 4 pounds of cobalt per acre, which can be sourced from local rock dust or from sea salt, right, is all it would take to ensure the capacity for life to flourish again. So I suggest, understanding the role of these critical elements and addressing them systemically is really, at the core of viable farm enterprise. So I think I'm probably running out of time. I'm not sure how much I've got left, but I do want to talk about quality and flavor and taste and all that.
I think you can go on for 5 minutes.
5 minutes.
Well, unless you just want to go on for 10 minutes.
I want to respect the time boundaries and everything else.
Carry on and then
All right, I'll try to come to a conclusion in short order.
we have a gap after this.
We do have a gap. All right, those who feel the need to depart should feel free. Okay, so that was principles of biological systems, roughly, broadly. I do, run an NGO. I didn't say that. When I came to this process of understanding as a farmer and began to see the results and said, my God, I grew up in the organic farming world and, my parents run this organization, and for 25 years, I haven't heard a whisper about any of this stuff. I bet there's a bunch of other farmers who are struggling with the same issues I'm struggling with, and I felt a compulsion to share this stuff. And so we now have an organization called the Bionutrient Food Association, whose mission is to increase quality in the food supply. We've identified nutritional value, flavor, aroma as, we think, a high ground upon which the deeper, broader community can coalesce. I personally believe there's deep insight and wisdom in the permaculture community, in the biodynamic community, in the organic community, in the conventional ag community. I mean, all the different streams of thought in agriculture, I think, have critical pieces of information. No one of them seems to really have teased it all together. And so what we're trying to do as an organization is to say, look, let's take this wisdom from here, and this wisdom from here, and this wisdom from here, and let's use the health of the plant, the quality of the food it produces as the guidepost about how good of a job we're doing. And so that's really our mission, increasing quality in the food supply. You know, in my 20s, I didn't talk about this before, I would manage my parents' farm in the summertime, and then I'd go off and be a radical of various sorts in the wintertime. Traveled the world, did all kinds of fun stuff. But came to the conclusion that, you know, the effort to improve the world, to save the world. Anybody else had this underlying desire at any point in their life to have some positive impact? Like really just sort of like, it just like, ugh, I just can't get it out of my system. I struggled with that for some time because it felt like any effort to address this issue or address this issue came up against some stoppers that were, I just did not have the capacity to overcome. And so, you know, what we have been thinking in the organization, and now it's really becoming much more of a broad-based process, is that if we can organize self-interest around this question of food quality, we might have the capacity to really achieve some larger accomplishments. I haven't talked really about the connection between plant health and food quality, plant health and pest and disease resistance, but very simply, as the plant is able to get more of its needs met through a more well-functioning microbial ecosystem, it is able to build compounds that are more sophisticated and complex, which then give it functioning pest and disease resistance, but also increased nutritional value and flavor. Let me just take a second to talk about pest and disease resistance because it's important. If there was a bale of hay in here somewhere when everybody walked in, you might have considered sitting on it, but you likely would not have considered eating it, right? And if a cow walked in, she would not likely have considered sitting on it, but she might have considered eating it. This is probably common sense for everybody here. What's food for a cow is not food for us. We know this. Why? Because the cow has 4 stomachs and she can digest what we cannot digest, right? Okay, nothing complicated there. Understand that the larval form of an insect has a much less sophisticated digestive tract than we do. Our digestive tract is less sophisticated than a cow's. Insects are less sophisticated than ours. Bacteria and fungi actually have less sophisticated digestive tracts than we do. So, as an example, the larval forms of insects do not have livers. They do not have the enzymes in their gut necessary to digest protein. Protein is a compound. It's built out of amino acids. There's this process of building compounds that goes on in a plant. You start with the sugars, you go to carbohydrates, you go to proteins. As soon as you're building proteins in the plant leaf, it is indigestible to larvae. Full stop. End of conversation. After proteins is lipids. When you're building high levels of lipids, fats, and oils in the plant leaf, it's physiologically indigestible to fungi, right? The blights and the mildews and things like that. After lipids are built, what's called plant secondary metabolites, those compounds which interestingly correlate with flavor and aroma for us. When you are building high levels of plant secondary metabolites, it is physiologically indigestible to the beetles, to the adult forms of insects. That plant is only digestible to animals. So I would suggest if your plant is digestible to insects, you're producing insect food. If your plant is digestible to fungus, you're producing fungus food. And only when it's animals that are the pests that are eating your crops are you properly producing animal food. Nothing too complicated. Those compounds, those secondary metabolites that correlate with flavor and aroma, are at higher or lower levels in crops, depending on how healthy they were. People may have had the experience of eating a tomato off the shelf in January that really had the flavor more of a cucumber than a tomato, and you may have had the experience of eating a tomato fresh off the vine in August that was a really exquisite experience. You know, peaches. Ever buy a peach from the store and have that really, I gotta chaw into it because it's hard and basically has no flavor? Ever eaten a peach that was ripe off of a tree? You're an animal. You're hardwired with a really sophisticated nutrient monitoring device called your nose and your tongue. You have the ability to discern relative nutritional value, which correlates directly to your health and vigor and vitality. And you know, average nutrient levels as monitored by national agencies since the 1930s have been going like this. Average nutrient levels have been decreasing. Average, levels of degenerative disease, cancer, heart disease, osteoporosis, diabetes are going up. Right? Mineral levels are going down. Degenerative diseases are going up. Our suggestion is that there is a global issue now with disease that correlates very nicely with food quality. And as we get more and more people who are sick and more children who are sick, the desire in the broader consuming populace for solutions is increasing. And so our thought is that if we can help consumers identify food that is more nutritious and choose that off the shelf, then we can apply an economic driver to the agriculture system to inspire farmers to do a good job increasing crop nutrient values, which will sequester carbon, which will obviate the need for fungicides and insecticides and fertilizers, et cetera. Does that all roughly make sense to people? Some of you have passed out due to heat. I apologize. I don't have much control over that. So foundationally, this vision is that if we can get consumers to be able to choose crops that are more nutritious, we can economically incentivize a transformation of the way farming is done and health of the landscape and the species. So technologically, the way that is possible to give a consumer the ability to test quality is through a technique or a piece of science called spectroscopy. There's a star about 5 or 6 light years away called Alpha Centauri, which is much farther away than any of the probes that we've sent off of the planet, right? I think it was the Voyagers that have gone about to the end of the solar system, which is maybe a light couple of days, a light week. I'm not sure exactly how far the end of the solar system is, but Alpha Centauri is light years away. And ask any astrophysicist, and they'll tell you with great confidence that Alpha Centauri is made up of 51% hydrogen, 48% helium, 1% other gases in certain levels and ratios. There's great confidence with what Alpha Centauri is made up of, even though no one has been there to sample it. And that's because every element in chemistry, right? Hydrogen is an element in chemistry. It's a vibration in physics. Hydrogen vibrates at a certain speed. Helium is an element in chemistry. It's a vibration in physics. And so by taking a picture of the light coming off of Alpha Centauri, we can identify what it is made up of. And our thought is basically that if we can do a mineral assay of Alpha Centauri from 8 light years away, we should be able to do a mineral assay of a carrot right in front of us. This is spectroscopy. And so we've had this idea for many years. At this point, the capacity to mass produce at a consumer price point a handheld spectrometer that consumers could use, which they could take to the grocery store to go to this bag of carrots and go burp, burp, grab, burp, burp, grab, burp, burp, decent, and literally choose the most nutritious crop off the shelf. That technology is now just coming upon us. And so that's part of what we're working on broadly as part of this larger endeavor. I've got here the first generation of our first generation prototype of our tool. We're an NGO. This is it. It's just a piece of plastic with a circuit board inside, but you can get your sample in there, flash a light, and it'll come. The reading will spit out on your smartphone. You can see what's in it. This is right now in the prototype form. We're building the data sets. The issue is not really building the tool. The issue is identifying quality. We know with our tongue, this carrot is good, this carrot is bad. We don't know in science, these levels of carotenoids, this level of copper and zinc is good, these levels are bad. We don't have that definition, so that's part of what we're doing right now, is identifying the spectrum of variation in nutrient levels, and most importantly, what are the causal dynamics? Which, in this soil type, which fertility programs, which cultivars, which management practices will correlate with high quality crops and not so high quality crops, so that we can actually give farmers real-time guidance, literally take this thing out, flash a light at the leaf, give us a few data points about your soil type and fertility program, and we can give you best practices guidance, right? Not we all input into the data set, we all monitor and study and sample together, And then with algorithms and big data and all this fancy stuff that computer people do, we can basically tease out best practices guidance to growers. And so anybody who wants to be part of this collaborative process can be working to produce healthier plants that need less fertilizer, that have less pest and disease pressure, that are more functionally, economically viable. And those people who are staying with the chemical system are basically going to be outcompeted. That's our vision of how it can all work. So at this point, I probably have taken more than my 5 minutes. Just one concluding statement. You know, I am the executive director of a NGO, and we are a member of this broader campaign called the Real Food Campaign, which has many members, organizations, NGOs, companies, universities, et cetera. This is a collaborative process. Everything is open source. The engineering for the tool, the data set, the calibrations, everything is in the commons. Very specifically, it does not belong to any company. Very specifically, it cannot belong to any company. It is a foundational philosophical position that this should be available to all smallholders everywhere and never be something that one must pay money for. I'm happy to talk to people about it later. If you want to just keep an eye out for us on the internet and see how things proceed over the next few months and few years. We expect these tools are going to be available for anybody who wants to collaborate with us to do data collection at the end of the year for $300. We're hoping that by the end of next year, the first generation of the calibrated handheld tool will be available for consumers, and probably in 2020, the hardware will be in some new smartphones. So it doesn't actually need to be a separate tool. It'll actually literally be in your smartphone. So it's quite exciting how it's all transpiring. Thank you.
For anybody at the back who wants a seat, there's plenty of seats down here. First question over here.
Paul Cherry, host farmer. Dan, thanks for a great talk. Your experience with your spectrometer, does it stretch to, because obviously a major part of what we've been on about this over these couple of days has been pasture-fed livestock.
Yeah.
And I know in America you've got a lot more advanced with sort of the premium product of a pasture-fed animal. Can you pass on any of that experience with your nutritional work?
Yeah. Right now we're building the data sets and we're building the calibrations, but there's no reason that it should not be able to work for milk, for meat, for grain, for vegetables, for fruit. Basically anything in chemistry is a vibration in physics. We understand when it comes to meat and milk, as an example, that the omega-6, omega-3 ratios vary greatly based on what the animal was eating. And so, yeah, can you identify if it's 1-to-1 or 6-to-1? Absolutely. Yeah, no question. So, yeah, I mean, basically the idea is that the labeling, the marketing, the certifications that seem to be, blowing up all over the place and sort of confusing the consumer, we can move right beyond that, right? I mean, I like to think of it as religion versus spirituality, if I may take that liberty. Is there someone mediating your relationship between you and truth, or are you directly perceiving it, right? At this point in time, you need to trust the label or trust the marketing or the certification system, and for many reasons you shouldn't. And we don't really have an alternate mode except to go to the shelf, take a bite of the carrot, say, I don't like it, and put it back, which most people probably are not going to do. So certainly we're never going to have anything, I don't think, that'll be anywhere near as sophisticated or personalized as your tongue. But we can, in this collaborative manner, come up with something that is much more, honest, true than a certification system. There are some organic crops which are nutritionally very devoid, and some organic crops which are of quite high quality. Some conventional crops which are nutritionally very devoid, and some conventional crops which are nutritionally very, very good. And there's no way right now to tell. So yeah, it applies to animal products as well. That was your question. Was that your question?
Yeah, I think I was sort of saying that if you're feeding cows on grass, which is what they're meant to eat,
yeah.
does it automatically make them better meat?
Well, some grass has 1% lipid levels, and some grass has 5% lipid levels. right? Some dairy operations, if you offer grain to a cow, they won't touch it, right? When your lipid levels are high enough in your grass, when your Brix levels are high enough in your grass, you're really going to have those compounds that are what the cow is wanting to eat. Some grass just is not at par, right? And so you can feed the cows grass, but they're going to lose their color. They're going to lose their conformity because the grass isn't healthy. So there's variations within all these continuums. And I mean, I've got my little personal pet peeves, and one of them is that people presume that the quality is high because the animals ate grass. My understanding is if the grass or the pasture, which is more than just grass, hopefully, is of really high caliber, then we will have high quality milk or high quality beef. But that's not always the case. Yeah.
Hello. My question is, have you any evidence or data for people becoming more ill and ill since food contains less nutrients because people become older? So that's a fact too.
Yeah. Well, there's, as in most cases with science, depending on how you define science, you can find arguments that make any case you want. There's a database called Dr. Duke's database. I think he's from the States, but I think you can read it anywhere, which correlates very nicely specific mineral deficiencies with specific degenerative diseases. So we can say, with some confidence that chromium deficiency correlates with diabetes. It's not just generally mineral deficiencies correlating with disease. We actually have it teased out. I didn't have time to go into the biochemistry and the enzyme system pathways, et cetera, but genetic markers, these sort of breaks in their DNA, are functionally there because the enzyme that was supposed to screw those pieces of DNA was not present, and at the center of that enzyme was an element. And so we can say chromium deficiency can give you the genetic marker that correlates with diabetes, and that genetic marker, and excitingly, that only comes about when you have had a lack of chromium in your diet for some time. What happens when you return chromium to your diet as your body rebuilds itself is that genetic marker will fix itself. So certainly there are other factors in nutrition, other factors in health besides nutrition. I'm not going to say that it's just the quality of food that matters. There's other things like, are you sitting in front of a computer all day, right? Are you being fried by wireless all day? Are you in a stressful relationship? Are you drinking, water that's full of chlorine? There's all number of other factors that affect functional health. But I think there's Albrecht's work. There's a number of people who did pretty good work showing the connection between mineral levels in food and functional vitality across the population. Yeah.
Hey Dan, could you elaborate a little bit more on the practicalities of inoculating seed and how to go about it and the methodologies around that?
Specifically, practicalities of inoculating seed, presuming a dry powdered inoculant, which is effectively what I was describing initially. You open this inoculant packet, you open the seed packet, you take a pinch out of the inoculant packet and put it into the seed packet, close the seed packet, and shake it up.
Maybe more the DIY.
The DIY, how to make your own inoculants, I don't think I've got time for that right now. Look up the term indigenous microorganisms, IMO, online. Basically what you need is a 5-gallon bucket or a plastic bag and to go for a walk. Hit as many microclimates as possible. Look for plants that are vigorous, pick up a handful of soil, stick it in your bag or your bucket, go back home, add water, mix it up, and then you will have those microbes standing in suspension and you can put them into a cedar or through a foliar sprayer, et cetera. Indigenous microorganisms would be a term to look up. People are familiar with compost tea, they're familiar with bokashi, they're familiar with Korean natural farming, perhaps. There's all number of techniques that have gained popularity and being disseminated out there. Certainly, it is entirely plausible to do all of this stuff from local materials with little, if any, money being used. And that's part of what we like to talk about in our organization. I will say I've condensed what is a totally full 2-day course into 45 minutes. And if one does want to get a deeper experience, that course is freely available online. If you search my name or our organization, you should be able to find it on YouTube. So we are an NGO. Our objective is to educate and empower. We're not trying to sell things. So, hopefully this has been a teaser and some people will feel inspired. And if you are the kind of person that binge watches TV, try binge watching YouTube. Or you can download it and listen to it while you're driving the tractor. Yeah.
Yes, hello Dan, I'm Jennifer Brodie from Riemann, a volcanic rock dust from Scotland.
Yes, yes.
Yes, and I know I have to be careful because I do want to sell Riemann volcanic rock dust, but
Yes.
I've been driving force 14 years.
Are you part of the Sears Center?
Yeah.
Oh, beautiful.
Well, no, yes, I worked there for 10 years, but
Okay.
and now I do my own product. And it's fantastic to hear you talking about what you're doing, but I'm interested in the States. They've got Remineralize the Earth, RTE, remineralize.org, and I just wondered how much that features in the States in what you're doing.
Remineralize the Earth was the beginning of my professional career in the NGO world. I started off as the executive director of Remineralize the Earth. My thought as a farmer was, while remineralization is extremely important, there's more to it than just rock dust. And I felt like that message was not being well conveyed by Remineralize the Earth, and so I founded the Bionutrient Food Association to sort of broaden the message. For me, as a farmer, to farmers, I wanted to sort of flesh it out. I have a great relationship with Joanna, still, consider her a close ally, and, have known about you guys for 15 years, so, or Sear, not you necessarily, but yeah, remineralization is really powerful. It's what the glaciers do. I like to say quickly, maybe I can just conclude on this point because maybe it's a practical thing besides inoculation. Anywhere you've got blacktop, right, where the roads are paved, the ingredients in blacktop are crushed rock and tar. The tar might come from Alberta or Venezuela. I'm not sure where you guys' tar comes from, but the crushed rock comes from a hole in the ground, probably nearby, because it's not efficient to ship rock too far because there's plenty of it. And so the process of quarrying is one where you drill a little hole, put some explosives in, blow it up. You got the bucket loader comes and picks up the chunks of rock, dumps them in the truck. Truck takes them to the crusher. The crusher crushes the rock. There's screens. The screens take off the 2-inch stone and the 3/4-inch stone and the 1/2-inch stone. And there's a waste product. That waste product we call it crusher dust or float or fines, and is oftentimes dumped back into the hole. That finely crushed rock dust is available all over the planet, generally for $2 a ton or $4 a ton or $8 a ton. It generally costs more money to rent a truck to go and pick it up and haul it back than it costs to fill it up. So as far as I'm concerned, it is a really powerfully valuable local resource that, because no one can really make that much money on it, has not been marketed and no one really knows about. It's one of those things where if somebody can make money on it, they'll label it, market it, and sell it and make a profit. If no one can make money on it, then no one gets told about it. And so generally the basalts, the volcanic paramagnetic basalts, are the highest caliber materials, no question. If you've got no basalt in your area but you've got granite, I would say go for it. Limestone does not count. Don't use limestone and say I told you so. I told you so, because I didn't. The basalts are the best, and granites are also very good. But I would stick to those two families of rock. And sea salt also is very valuable. I suggest 75 pounds of sea salt or rock salt per acre per year as a wonderful prophylactic dose of minerals. You can certainly get into greater nuance with rock phosphate and green sand and copper sulfate and cobalt sulfate and solubor. That's a totally valuable strategy, but you can also do it through the really raw, naturally occurring materials as well. All right, thank you.
Goodness me, thank you very much. It's given us all lots to think about. Give him a round of applause.